Hello student, welcome to the digital signal processing. Last time we have discussed about the vocoders. Let's discuss the channel vocoder, that is also called as a coders. So in the channel vocoder, as we have seen in this particular block diagram, speech is nothing but the input, then the ADC block, then the filters. Total 16 filters will be here. Then the rectifier circuits after this filter, and the low pass filter circuits again used. So whatever the pitch we detected over here, directly it is used to give the output to the mux block, and lastly we are getting the coded output. So in a shorter way, this can be described as a speech is split into subbands for spectral envelope detection. So envelope detection is vocal tract modeling. Then the pitch detector estimates the frequency and aids in distinguishing voiced and unvoiced segments. So that is what the role of this speech detector. Outputs are multiplexed to produce coded speech signal. So while discussing this channel vocoders, there are supplementary parts like the channel vocoders split speech into increasing non-overlapping frequency subbands. The whole range covers the frequency that human can hear. Incoming speech is periodically sampled, typically every 20 milliseconds. The channel vocoder uses a multiplexer to send two different categories of information on the same channel. To multiplex two signals by taking a sample from the first and then second sequentially. The same cycle continues periodically. The sampling rate for all signals must be above the Nyquist limit. These samples may then be transmitted as a single signal. A demultiplexer circuit on the receiving end can easily separate each signal since it knows the timing of the samples. This multiplexing scheme is called time division multiplexing, that is TDM. The multiplexer of the channel vocoder, that is coder, operates in a similar fashion. It enables two different groups of signals to be transmitted on the same wire without significant crossover. Once the bandpass filter divides the speech into smaller frequency groups, each subband is rectified. Every subband is further rectified and low pass filter to determine the spectral envelope of the speech. They are then digitized and multiplexed for the transmission. There are usually 16 subbands covering the whole of the audible frequency range. The speech is also analyzed for the pitch of the sample. For voice sounds, the estimated frequency is multiplexed and transmitted. For unvoiced sounds, since they do not have pitch, only an indication for their existence is coded and transmitted. A pitch detector tries to distinguish between the voiced and unvoiced segments. It is quite easy to identify voiced segments with clear periodicity and unvoiced segments which are non-periodic. However, it is very difficult to assess segments that fall between these two extremes. There are a number of voice detection algorithms developed, but none performs well in all applications. In summary, the channel vocoder analyzes the incoming speech signal by three major categories, that is speech spectral signal envelope, then the pitch and the amplitude. So extracted information is then multiplexed and transmitted. Such analysis does not look to preserve the originality of the speech, but tries to compress it without losing the ability to understand it. That is all about the vocoders in case of the channel, or we can say as a coders. Let's see the next part, that is called as a channel vocoder in case of the synthesis. So in the synthesis we simply defragment, which is just we have seen that it is to get certain speech recovery. So whatever the signal that is transmitted, it will be simply decoded, and then the speech is expected to be at the output. So let's see the channel vocoder, that is the synthesis part. So here the synthesizer reverses the coding process. The first thing is the received signal demultiplexed to separate out different information categories. So here the different information categories are being separated out. The part of the signal carrying the spectral envelope information is then converted to analog. So that is what done over here. If it is from the voice pitch segment, estimated pitch frequency is used to fill in the spectral envelope. However, if it is from unvoiced segment, the random noise generator is used. So that is what done over here, random noise generator, to regenerate the sound. Finally, the signal segment is band pass filtered. So this is how it is band pass filtered. Its original frequency range. So from the block diagram of vocoders, it is quite apparent that most of the blocks can be implemented with contemporary DSPs. Filters are particularly easy to implement and their processing is well within the range required by the speech signals. There are a number of pitch estimator algorithms already implemented using DSPs. The processing power of DSPs and their sustainability, as well as the suitability for signal process, make it possible to implement efficient pitch estimator. So this is what the channel vocoder and the synthesis. Let's move to the subband coding. This is what we have seen earlier. When the input is accepted, it is simply filtered over here. Next, downsampling will be done and the coder block will be there. So this is nothing but the analysis part. This is nothing but the synthesis part. So at the synthesis, whatever the output we got from the analysis, that will be decoded. Then this is where the upsampling will be done, exactly reverse to that of the analysis. And once it is done, then reconstructor block or the filter bank is applied to get the original sequence. Now the encoding at the transmitter can be easily explained over here. So this is the summary of the earlier blocks. In short, low pass filter, high pass filter will be used over here. Downsampler will be used here. So these down arrows indicate it is the downsampler. Then again it is passed through the filters and again downsampled. So this is regarding the transmitter. This one is regarding the synthesizing at the receiver. So whatever the signal we got, it will be upsampled over here, then again filtered, upsampled and filtered. So this is all about the concept of vocoders as well as the process of analysis and synthesis. So thank you everyone. Thank you very much.